If you were to live an average of 80 years, 1 part per 10 of your life would be 8 years long. 1 part per 100 would be 292 days. A part per 1,000 would be 29 days. A part per 100,000 would be 7 hours. A part per million would be 42 minutes. This year, each class period is 2 parts per million of your life that I take. You're welcome. A part per billion would be 2.5 seconds, and a part per trillion would be 0.0025 of a second, super small. When we talk about toxic things, oftentimes we talk about really, really small concentrations, like part per billion, part per million. In order to get those concentrations, we need to do something called a serial dilution. Serial dilution, as in something that comes one after the other, not the stuff you eat in the morning. Serial, like a serial number, or like a serial killer, serial dater. One comes after the other. This is a serial dilution lab. You will need some toothpicks or something like toothpicks. You'll need your pipette. You will need some food coloring, and you will need some small containers. So in your notebook, you're going to make an area like this worksheet. I'm going to give you a copy of this worksheet. You could print it off, or you could just make it in your notebook. You're going to need 12 circles, 12 circles like this. And you're going to need 12 little containers as well. I'm using these well plates. You can use any little container that you want. Into all but the first, you're going to put 9 drops of water into each of the other wells. All right, now you're going to take food coloring. I would recommend red or maybe blue, but not yellow food coloring. You're going to put a couple drops into the first well. Actually, just 1 drop is probably enough. We're going to consider that a 1 to 10 ratio. I don't know if it really is true, but we're going to just use that for this lab. You're going to take one end of a toothpick and get a little bit of it and smear it into that first circle. That's a 1 to 10 ratio. Now, we're going to take 1 drop from there and put it into the one with 9 drops of water. I'm just going to use my original container. I'm going to take the other end of my toothpick and stir that all up. I'm going to take a little bit of that and put it into circle number 2. I can now discard this in the trash because I've used both sides. Now, I'm going to take 1 drop of this and put it into the next one. I'm going to take my pipette. It's now dirty on the inside, and I'm going to rinse it out with some water. So just the way that I'm rinsing it out is just squeezing in and out with some water. So make sure I'm cleaning it off so I can use it again. I'm going to take a new toothpick, stir this up in here, and put it onto there. Now I'd like you to just guess. Put a little star where you think you're not going to see the red anymore. What you're going to do is you're going to continue this each time. You're going to take 1 drop from here and put it into here. Stir it up with a new side of a toothpick and put some down here in the next circle. Then you're going to take 1 drop from there and put it into there. You're going to dilute this by 10 times each time. You're going to do this for all 12 circles. Make sure to wash and rinse your pipette in between each one. As you saw from the reading, 1 part per 10 is the same as 100,000 parts per million and 100 million parts per billion and 100 billion parts per trillion. As we dilute this by 10, our ratio is now 1 to 100. The next ratio is 1 to 1,000. This trend continues through the whole paper. However, instead of 100,000 parts per million, now we are at 10,000 parts per million and 10 million parts per billion and 10 billion parts per trillion. This trend also continues throughout the whole paper. Here, you'll get to 1 part per million. The next one after that is going to be 0.1 part per million. Can you guess what comes after that? 0.01 parts per million. Fill in all the numbers of this worksheet and then answer questions 1 through 9.